Here we have a SAT math question on circles. Okay, let's go over the question. In the figure above, each of two circles has the same center O. If OP to OQ equals to 3 to 5 and the area of the shaded region is 40, what is the area of the larger circle? Here, the ratio between the two radiuses of the circle is given, that is OP and OQ. So, in the picture, OP stands for the radius of the smaller circle. We can name it as R1. And OQ stands for the radius of the larger circle. We can name it as R2. Okay, the ratio between the two radiuses of the circles is given, that is R1 to R2 equals to 3 to 5. So there is a ratio between the two radiuses equals to 3 to 5. Okay, from this ratio I can find the ratio between the squares of the two radiuses. That is, I have to square both the radiuses and I'll be getting R1 square to R2 square equals to, so on the right side also we have to square the terms of the ratio, then I'll be getting 3 square to 5 square. So the value of 3 square is 9, the value of 5 square is 25. Okay, now I got the ratio between the squares of the two radiuses. In whatever ratio we have the squares of two radiuses of the circle, in the same ratio we'll have the areas of the two circles. That is, the area of the smaller circle to area of the larger circle is equal to 9 to 25. So because we have the radius of the smaller circle first, so I am writing area of the smaller circle first. So because I am saying in whatever radius, in whatever ratio we have the squares of two radiuses, we have the same ratio, we have areas of the two circles, because in area formula we have pi r square. So for example, pi r1 square represents the area of the smaller circle and pi r2 square is the area of the larger circle. If I find the ratio between them, I find that the common divisor for these two terms is pi. So when I divide both the terms by pi, this pi will cancel out, here will cancel out. So I get r1 square to r2 square. So this is the ratio of the areas of two circles. So that's why I'm saying in whatever ratio we have the squares of the radius of two circles, the same ratio can be taken as the ratio between the areas of two circles. Okay, now I got the area between, the ratio between the area of the smaller circle and the area of the larger circle, that is 9 to 25. Okay, so from this ratio 9 to 25, if I want to get area of the smaller circle and area of the larger circle, what I need to do is I have to multiply the terms of the ratio by the same non-zero number, say x. Then area of the smaller circle will be 9x and area of the larger circle will be 25x. So whenever I want to get original quantities from the terms of the ratio, I have to multiply the terms of the ratio by the same non-zero number. So usually it will be unknown. So we'll be multiplying by x. Okay, now I got the area of the smaller circle and area of the larger circle in terms of x. Okay, to get the area of the shaded region, what I need to do? I have to subtract the area of the smaller circle 9x from the area of the larger circle 25x. So this gives me the area of the shaded region, but it is already given in the question itself, that is 40. So it is equal to 40. Okay, let's solve for x. 25x into 9x gives me 16x equals to 40. Okay, so now to solve for x, I have to divide both sides by 16. So this 16 will cancel out. And so both 40 and 60 are multiples of 4. 4 goes into 40 10 times. 4 goes into 16 4 times. So we get, and further 2 goes into 4 twice and 2 goes into 10 5. So we get 5 over 2, which is 2.5. So I got the value of x. Okay, now so that here I multiplied both the terms of the ratio with the same non-zero number x, but now I got the value of x 2.5. Okay, now according to the question, I have to find the area of the larger circle. Area of the larger circle is given by 25x. So to get the area of the larger circle, we have to plug in x is equal to 2.5 over here. Okay, let me plug in 25 times 2.5. Okay, so here the 25 times 2.5 is 62.5 square units. So the area of the larger circle is 62.5 square units.